Ladies and gentlemen, return your radios to their upright position. Prepare for takeoff with America's First Lady of Liberty. A voice, not left, not right, but truth-centered. Now, from the live free or die sovereign state of New Hampshire, raise up another rousing cheer for that Doctor of Digital Privacy. Ladies and gentlemen, Dr. Katherine Albrecht.
Hello and welcome to the guest segment of today's radio broadcast. I'm delighted to be talking about something that is apparently on a lot of people's minds, and that is, how did we get here and where are we going? Well, there's a couple of explanations for how we got here, and the one that's been with humanity from the very beginning has been, well, God put us here, and we were created through a process known as intelligent design, meaning we were designed by an intelligent creator. And in my book, that's God himself. Most people have some definition of what they believe that process entailed. But it turns out that we're pretty much evenly split across America between those who believe that we were intelligently created and that we just sort of evolved from a soup of accidents and coincidences that led to all of the complexity that we see around us. Well, the mainstream media would have us believe that the only people who believe in intelligent design are people who are, well, uneducated, maybe not academic, haven't really looked deeply into the issues, don't have a scientific background. But I myself, who have a doctorate from Harvard University, and my upcoming guest who spent a lifetime studying science and is an academic as well, in charge of the Discovery Institute Center for Science and Culture, believes that, hey, there's more to the story, we ought to be talking about it. And please join me in welcoming Stephen C. Meyer to the program. He is the New York Times best-selling author of the new book called Darwin's Doubt, The Explosive Origin of Animal Life and the Case for Intelligent Design. Hello, Stephen.
Hey, it's great to be with you. Thanks for having me on.
Well, it's great to have you on, and I want to get just a little bit of background on how you came to this position. Were you raised sort of believing in intelligent design? Did you come at this after years of study and contemplation? How did you come to this conclusion?
Well, I was as a kid really fascinated with science, especially natural history. I was fascinated with dinosaurs and trilobites and stories about ancient man and all of that, and pretty much about the standard evolutionary line because I hadn't learned anything else. I did a undergraduate degree in physics and geology, took a lot of philosophy along the side. My first job was in the oil industry in Texas. I was a geophysicist, and I was working in the area of digital signal processing, which was an early form of information technology. A conference came to the city where I was then living that was addressing the big questions right at the intersection of science and philosophy, the origin of the universe, the origin of life, and the origin and nature of human consciousness. That was the topic of this amazing conference.
Wow. Okay.
And I found out about it the night before, attended, and there were leading scientists who were on one side of the panel, theists, who believed in God, and on the other side of the panel, materialists or atheists who didn't. And they were debating these three big issues, and I was just fascinated and particularly got hooked on the discussion about the origin of the first life, because it turned out that the big unsolved problem that everyone acknowledged was the problem of the origin of the information, the digital code stored in the DNA molecule that's necessary to build proteins and therefore any form of life on Earth. And you can't explain the origin of life if you can't explain the origin of the code. And that was the problem that everyone regarded as at that point, and still, an insoluble problem from the standpoint of standard materialistic evolutionary theories. A year later, I met one of the scientists who was on that panel, got to know his work really well. A year later, I was off to grad school in Cambridge, England, and I ended up doing a PhD in the philosophy of science and focused my PhD work on precisely this question of the origin of the first life.
Wow. All right. So now help us understand what this dilemma is, because we've all been raised on the account that certainly started with Darwin and has now become kind of the canonical accepted account that there was a primordial soup, and there was hydrogen, and there were all these gases floating around, and all these minerals, and then there was some kind of a lightning strike, who knows what, and somehow it just sort of came about. And I don't think that any of us have really sat down and tried to figure out exactly what that entailed, but we've all kind of accepted this notion that something happened, and it started with maybe a little something that we might replicate in a test tube, where some little molecules kind of got together, and then suddenly there was life, and then the life got more and more complex, and then a couple of million years later or longer, then here we are. So what? Little
time, little chance, a few somehows, and there you are, right?
Yeah. Right. We just kind of skip over the hard parts, as I just did.
Don't get too much into the details. Well, it's the details that are actually the problem. And there's two contexts here. There's two different branches of evolutionary theory. One is biological evolution, and that's the part that Darwin developed. That's how do you get from a simple, pre-existing living form, like one of the first cells, to all the things we see today. And then the prior question is, how do you get from the chemicals in that prebiotic soup to the first living cell? One is called chemical evolution, and the other is biological evolution. Let's start with the chemical evolution, because you talked about the soup. And that's what my first book was about. It's called A Signature in the Cell, and it was based on a lot of the research I did in grad school, in fact. The problem there is that essentially the chemistry doesn't do what we want it to do, or what it would need to do if we were to be able to explain the origin of life from chemistry alone. The chemical reactions tend to move away from a life-friendly direction, and nobody's quite figured out how you get from pure chemistry to a molecule like DNA that encodes information. In fact, the constituent parts of the DNA molecule, the sugars, the phosphates, and the all-important bases, which actually function like alphabetic characters in a written language, are completely inert, if you will. They're indifferent to how they're arranged. But the information in the molecule is all about the arrangement of those letters that are functioning like bases. So the chemistry doesn't actually determine the information content of these important molecules. And yet the whole idea is of chemical evolution, that the chemistry alone, through various undirected reactions, would lead to these information-rich molecules. The chemistry just seems to be dumb. It doesn't want to organize itself into information. And one of the ways that's been really interestingly demonstrated is that the most cutting-edge theories about the origin of life from a naturalistic or materialistic point of view are called the RNA world theories. And they're trying to get a molecule called RNA, which stores information like DNA, but it may have some catalytic properties like proteins, and they're trying to get that to be the starter molecule, the molecule that will copy itself and get natural selection going. But to even get an RNA molecule that will copy a little bit of itself, and that's all we've been able to achieve in the lab, one that will copy maybe 10% of itself, the chemist has to very carefully engineer the arrangement of the chemical parts. Again, these bases, as they're called, that function like alphabetic characters in a written text. And so to get the molecule to copy itself, it's got to be information-rich to start with. But to get the information, you need the intelligent input of the chemist. So what's being simulated in these simulation experiments is actually the importance of intelligence in generating information.
So let me make sure I'm following this, because the real problem is a level of complexity that perhaps we need to explain to people, that the information contained in DNA and even in RNA is so incredibly complex. And it's funny, I just visited yesterday the Louisa May Alcott House in Concord, Concord, Massachusetts. And while I was going through this creaky, wonderful old home where Louisa May Alcott actually lived and wrote Little Women and patterned this after her sisters, bear with me, I'm going somewhere. One of the gifts that one of her sisters had given to their father was a lock of hair. And so here was this little circular lock of hair with a ribbon tied on it, and there was a little note in her beautiful handwriting from a quill pen, and it said, "I can't afford to give you more, but please know that this is heartfelt." And throughout the house, there were 3 other locks of hair, including that of Louisa May Alcott herself. And it occurred to me, if somebody snatched that, maybe they could actually clone Louisa May Alcott, because all of that is contained in a lock of her hair. All right, we'll talk more about this when we come back. Stephen Meyer is my guest. I'm Dr. Katherine Albrecht. Stay tuned.
the winds erase me.
Hey, we're back. Katherine Albrecht here, visiting with Stephen Meyer. His book is an absolute bestseller. If you don't yet own it, you want to get yourself a copy of Darwin's Doubt, The Explosive Origin of Animal Life and the Case for Intelligent Design. I've got a link up in the archives at my show archives at kmashow.com. Click on Radio Show, make your way to the archives, and I also have a link to the other books. You've actually been really busy writing about science, and I'm really grateful for all the work that you've done. And I love the way that you're raising this issue, Stephen, from a really scientific standpoint, because I think that's what's been missing in the discussion, is that it's been really framed as a discussion between science people who care about what's logical and makes sense, and then a whole bunch of people who are kind of fuzzy thinking, muddle-headed, haven't really thought through the facts, haven't looked at the science, and you're really turning that on its head. The book Darwin's Doubt, The Explosive Origin of Animal Life and the Case for Intelligent Design, as well as Signature in the Cell, DNA, and the Evidence for Intelligent Design. Obviously, major questions that people are asking. And because these questions are scientific questions, which you're raising, and I want to get back to Louisa May Alcott's hair in just a moment, because they're scientific questions that you're raising, I think it's really important that people recognize that this debate is occurring within the deepest levels of science, that this is not a debate, certainly it's occurring elsewhere as well, but that it is occurring within science, that there are well-known, renowned, competent, thoughtful, brilliant scientists all around the world who share this view and who have concerns over kind of a knee-jerk response that, hey, this all just happened by mistake. So let me get back to Louisa May Alcott's hair, the hair of her sister, with this lovely little note saying, hey, it's all I have to give you, but I hope you'll appreciate, Papa, this gift from me. And that was really a thing people did in the 1800s, is they gave each other locks of hair. And while it seemed kind of morbid to see these weird locks of hair in every room, it was a pretty typical thing. And I'm sure a lot of people have hair from their grandparents or great-grandparents or even ancestors from that era. Would it be possible to take some of Louisa May Alcott's hair, if we had enough technology, and actually create a baby Louisa May?
Well, it actually turns out that it wouldn't be. You can find Louisa May Alcott's DNA in the hair, but it turns out that life is even more complicated than we realized. We figured out in the 1950s that DNA was pretty critical and that it contained information. Watson and Crick had this, did all the work to elucidate the structure of DNA. Crick later figured out that DNA, he advanced something he called the sequence hypothesis, which was basically the idea that inside DNA there is this 4-character digital alphabet or digital code, and that DNA is literally storing information in the form of that code. But it turns out that information is necessary for building proteins, but there are higher orders of information now called epigenetic or beyond the gene information that's necessary for arranging proteins into different types of cells and different types of cells and different organs and tissues. And so just having a chunk of hair isn't going to get it done. You actually need the information that's in the architecture of the maternal egg. We are really dependent on these higher levels of information that we would inherit from our mothers. And so it's in principle not possible, I think, to clone a person from just the DNA.
Okay, so
kind of sad, maybe, I don't know. We call it the Jurassic Park fallacy, because that's the same idea that
that's
you get
really
in Jurassic Park.
Yeah. And I don't know if you're familiar. You may have written about this actually in your book. It might be where I got it, but that Madonna actually has a DNA cleanup crew that follows her around from hotel room to hotel room, using chemicals and vacuums and who knows what to remove any traces of her DNA. And presumably her concern is that someone could use that DNA in some nefarious way. What could one do with some of Madonna's DNA if one had it?
Well, I'm not exactly sure. We couldn't make a new Madonna. That's and that's either good news or bad news, depending on how people feel about Madonna, I suppose. But I guess she just doesn't want people getting cheap souvenirs. So
yeah, right, exactly. Yeah. There's some of her hair. All right. So, getting back to the overall question, then, if we haven't, and I know there's been a lot of experiments in laboratories at MIT and elsewhere where they've really taken the building blocks of life and put them together in petri petri dishes and hit them with lightning and hit them with all sorts of things, trying to get them to come to life, sort of like a Frankenstein's monster basement there. What happens when they try to do that? What is it that they're trying to accomplish, and what happens when they try it?
Well, this is, again, back to that early question of how do you get life in the first place from the simpler chemicals. And there are a host of what are called simulation experiments that have been performed trying to demonstrate the plausibility of a step-by-step increase in chemical complexity until finally you get to something that we would recognize as alive. And the basic problem is that there would be many steps in that, and the critical thing that would have to be explained somewhere along the way is the origin of the DNA molecule with the information it contains, because the DNA molecule has information, an instruction set for building protein molecules, and proteins are the crucial big molecules in cells that perform all the important jobs. They build, they catalyze enzymatic reactions, they function as enzymes, they process information, they fit together to form complex molecular machines. We're finding extraordinary little pieces of nanotechnology, nanomachinery inside cells, and all of those, the enzymes, the machines, the information processing capacity, all is accomplished by proteins, and the proteins are built in accord with the instructions stored on the DNA molecule. So to build a living cell, you've got to, at a minimum, find an explanation for the origin of that information stored in DNA. And what the prebiotic simulation experiments have tried to do is simply synthesize under reasonably plausible conditions the constituent parts of the DNA molecule or the constituent parts of the protein. There are big question marks over how plausible the conditions are, and so people are not really convinced that even that has been accomplished in a way that would simulate what was actually going on the early Earth. But even to the extent that they've been able to simulate the building blocks, the synthesis of the building blocks, they've not been able to explain how the building blocks all got arranged in a way that would carry information, carry those instructions that are necessary to build the proteins. And so the big problem is not the molecule, it's the information that the molecules contain, and the chemistry just hasn't been able to explain where that comes from.
Yeah, it's complexity of a mind-boggling level. All right, wonderful. I'm so fascinated. I have so many questions. I can't wait till we come back from this break to learn more. All right, Katherine Albrecht here, visiting with Stephen Meyer. He's the author of the New York Times bestseller called Darwin's Doubt. You can learn more on my website at kmashow.com. Stay tuned. All right, so Stephen Meyer, there's so many things I want to talk to you about, but let me cut to the real chase. Is there a creator? When we really get down into the complexity of not just the fact that there are jellyfish and peppermints and clouds and everything else, but when we get down into the molecular level, the DNA level, the cellular level, the atomic level, and we start looking at what really makes up life, what really the building blocks are of life and every other thing in the universe, what is it that causes you to look at that and conclude that there must have been a designer to put all of that together? Is that the conclusion you've drawn, and if so, why?
Yeah, it is. And there are many reasons, but one of the primary reasons has to do with what we've been talking about, that the striking, surprising discovery of late 20th century biology is that at the foundation of life lies information. Much of it is stored in the DNA molecule. We were just saying that there's other sources of information in living systems too. But what we know from experience, from our uniform and repeated experience, which is the basis of all scientific reasoning, is that information always comes from a mind, from a conscious, rational agent, not from an undirected material process. And if you just think about your own experience from it, if you think about a hieroglyphic inscription or a paragraph in a book or a section of software code, whenever we find information, we trace it back to its source. We always come to a rational agent, not to an undirected material process. And so the discovery that in every living cell of every living organism, we have information running the show and provides powerful support for the conclusion that a designing intelligence played a role in the origin of life itself. And that's in a sense, the positive argument that I develop in my two books. The negative argument is the various evolutionary processes have been shown not to be capable of generating the information, and certainly not the amount of information that's necessary to account for life. But the positive argument is that we know something from our uniform and repeated experience about what does cause information, and that known cause is mind or intelligence.
Yeah, it makes sense. Why is there so much resistance to looking at what clearly is a piece of software code, but a software code times a cajillion? Why is there such resistance within the scientific community to say, hey, hang on a second, the evidence really isn't adding up for this other explanation. It really is looking like maybe there was a designer here. That would seem like an obvious conclusion to reach.
Well, first of all, there is a lot of dissent that is not recognized or reported against the standard Darwinian or chemical evolutionary theories. There's a new journal called Inference, and it's running in its current issue a really powerful critique of the prebiotic soup chemical evolutionary idea that we were discussing in the previous segment. It's written by one of the leading experts in organic synthesis and nanotechnology at Rice University. So it's as you were mentioning, it's not like this is just a debate between the people who have the facts on the one side and people who have an irrational faith on the other. This is a scientific debate that's going on at the highest level. But to answer your question, I think the reason there's so much resistance is that since the late 19th century, since about the time of Darwin, science has become associated with a convention of reasoning known as methodological naturalism. It's a mouthful, but all it really means is that if you're going to be a scientist, you've got to limit yourself to materialistic explanations. You've got to explain everything by reference to undirected material processes. And anyone who breaks with that convention is no longer playing by the rules of the guild. The problem is there are certain kinds of things that we know from experience are not produced by undirected material processes, and information-rich code is one of them. And so if you genuflect before that convention and say, yes, I'm going to limit my hypothesizing to materialistic hypotheses, you're likely going to miss something, because not everything in the world is produced by matter and energy alone. Some things are produced by intelligent agents. If you were to walk into a British museum and look at the Rosetta Stone, you wouldn't say, gee, isn't it wonderful what wind and erosion did? You'd immediately recognize those information-rich etchings on the stone as the product of a scribe, of an intelligent agent. And if you're forced to exclude consideration of such agency in your theorizing as a scientist, you may miss what's really happened.
It almost seems as though, regardless of what the evidence might be, that there's a kind of a blinders on, saying we're not willing to go there.
Absolutely. Hear no design, see no design, consider no design. We're gonna plow ahead and try to explain everything with matter and motion, even though we know there are some things that aren't explained that way, that aren't produced by just strictly undirected material causes. So getting to kind of a deeper question then, it seems, and I'm thinking of the Thomas Kuhn and the Structure of Scientific Revolution here, that which I highly recommend everybody in the listening audience read, by the way. We'll post a link to it on. Excellent framework for understanding what's going on, actually. There is a kind of scientific revolution at work, and there is a very desperate attempt to suppress it. Exactly. And this has happened periodically throughout all of science, all of scientific development, that the structure of scientific revolutions, the whole concept of a scientific revolution is brave people like yourself come along and say, hang on a second, this is what we're seeing, and the evidence does not match what you guys are all saying. And then you guys say, well, get out of here. We're going to dismiss you. We're going to undermine you. We're going to stomp on you. We're going to try to pretend you don't exist or discredit you, until eventually the evidence becomes so overwhelming that the whole scientific structure has to change. That's what's known as the revolution. So I highly recommend that. I'm going to ask Tiffany behind the scenes here if she can post a link to that book, KUHN, Scientific Revolution, on our website. So anybody who's interested in these scientific debates,
States, obviously you want to start by reading Stephen Meyer's book, Darwin's Doubt, The Explosive Origin of Animal Life in the Case for Human, or for Intelligent Design, that is, Signature in Cell, DNA, and the Evidence for Intelligent Design, as well as Explore Evolution, the Arguments for and Against Neo-Darwinism. So you also have a DVD out, DNA by Design?
That's right, and a new little online video that people might find called The Information Enigma. It's 22 minutes, and it gets these ideas across. It's on. You can find that on my website, darwinsdoubt.com. It's up right now, and it's a nice way to get your head around what we're talking about and get into the subject.
darwinsdoubt.com. So I'm going to post that for everybody out there. If you're not into reading books, or if you don't have time, I know a lot of people are really busy, then the DVD DNA by Design is available also. So I encourage you to check out all of those. And if you're particularly interested in this concept that science really does try to suppress, you know, we think of science as being objective and it's only looking at the evidence and there's no biases, and that's absolutely nonsense, because the reality is that every great scientific breakthrough throughout history that has challenged the existing dogma has been suppressed, has been attacked, has really been really taken a whole lot of time and a whole lot of effort to overcome. And I think this is a great example of that. So what a wonderful service you guys are doing in standing up to this. Stephen Meyer is my guest, Meyer, author of the New York Times bestseller called Darwin's Doubt. I absolutely encourage you to check it out. You can find links to that, his website, and all the other information we've discussed on my website at kmashow.com. All right, stay tuned. We need to stand up for truth, and there are some things about the supposedly scientific view that life just came about by itself that aren't really holding up to scrutiny. And it's interesting because the accusation usually is, well, you're putting your faith above the facts, or you're putting your faith above science. And what's emerging now is very interesting, because we're finding exactly the opposite is happening. The people who are holding to this view that everything is materialistic and nothing had any kind of design are actually acting in their own degree of blind faith, in that they refuse to see the evidence that's right in front of them. So I encourage you, pick up a copy of this extraordinary new book called Darwin's Doubt, The Explosive Origin of Animal Life and the Case for Intelligent Design, along with all the other extraordinarily wonderful books that Stephen Meyer has written. Stephen, your books have hundreds and hundreds and hundreds of 5-star Amazon reviews. I don't think I've ever seen a book that's been as thoroughly reviewed as yours. Everybody, pretty much to a man and a woman, is in overt praise of this book. So that's got to be a really positive thing, that even if we're not getting through to the annals of science, we're getting through to the minds and hearts of people who like to read scientific books, if nothing else. So thank you.
Sorry, no problem. I was just going to repair back to your earlier point about Thomas Kuhn, because one of the things that he says, which is, I think, quite encouraging for us, is that scientific revolutions are produced by the rising generation of new scientists, that typically people who are very late in career, who become ossified around a particular point of view, are unlikely to change. Some do, but typically it's the rising generation. And we're seeing that. We have a summer program for promising PhD students, postdocs, and there's just so much young talent that really is excited about the new developments in biology and biochemistry and astrophysics and physics right across the disciplines. There's powerful evidence of design, and it's providing a new way of looking at life, looking at the universe, and making sense of everything. So it's
what were the implications?
And the younger people get it.
I think it's fabulous. And what are the implications? Because I have to say, as a scientist and as someone who follows science, that the idea that we could actually provide scientific evidence that there is somebody out there who's really darn smart and who made everything, that would be a groundbreaking, awesome, eye-opening, explosively exciting discovery, because it would mean, wow, then who is that?
This is what hooked me right back from that early conference that I told you about when I was in my mid-20s. And I'd always been interested in the philosophical implications of science and the intersection between science and philosophy. And it seemed to me that these new discoveries about DNA in particular were suggesting the possibility of reviving the classical or ancient argument from design. And if that were the case, this would be a hugely important scientific discovery. And so I set off to grad school with a kind of a burning question in my mind, and that was, could this intuitive connection that we sense between information and mind, could that be developed into a rigorous scientific case for intelligent design? And one of the ironies of my own story is that I spent a lot of time studying the works of Charles Darwin and studying the scientific method that he had developed specifically for investigating events in the remote past. And he had a very clear principle of reasoning that he put forward. He called it the vera causa principle, the true cause principle. If you want to explain an event in the remote past, you should posit only those causes which are known to have the power to produce the effect in question, the effect you're trying to explain. And one day I ended up asking myself a question, which is, what is the cause that we know of from our uniform and repeated experience that's capable of generating information, that's capable of generating code? And that was a breakthrough moment for me because I realized there was only one, and that cause is intelligence.
Oh, amazing.
So using Darwin's method, I came to a non-Darwinian conclusion. I guess that's
fascinating.
Yeah.
All right. So now I'm sure you've been asked this question before. Is it secretly your belief in God that caused you to do all of this research and sort of circle back to evidence for God?
Well, it's hard to say. With every person, the influences are different. I had a tortured conversion experience to Christianity through high school and college, and it took me quite a long time to settle in something that you would call faith. I had lots of questions, and it took me a long time to get answers to them. But I was initially quite comfortable with the idea that, well, evolution is true and God is also there. And, some people call that the theistic evolutionary viewpoint. So it wasn't really my belief in God that impelled me to question the evolutionary idea. It was more these new, the new evidence that I was presented with concerning the all-important code inside life, that the information-bearing properties of living systems seem to require a different kind of explanation than unguided, undirected evolutionary processes.
All right, now I'm going to throw one at you. How old is the universe?
I'm an old universe guy. I'm pretty convinced that the standard dating is correct of about 13 billion years. And I think the Earth is old as well, probably about 4.5 billion. But I'm skeptical that human beings have gone back way, way far. I think it's very interesting that we have the oldest evidence of agriculture we have is since the last ice age. The oldest cities are on the order of 10,000 years plus or minus. Writing has only been around for about 5,000 years. So our species seems to be a relatively recent advent. So I'm an old universe, old Earth, recent humans is my perspective.
Interesting. All right. Well, thank you for that. And now I want to mention that this coming Saturday, and this program is going to be broadcast on Saturday for many people, so this may actually be tonight for a lot of folks, is you are going to get into a heavyweight-style debate with Lawrence Krauss, an American theoretical physicist and cosmologist, quite a celebrity within those circles. He is going to be arguing for against your arguments for intelligent design. So tell us a little bit about that debate. It's going to be online at evolutionnews.org at 7 p.m. to 9 p.m. on Saturday night. And just to clarify, that's Saturday, March 19th, 2016. So if you're hearing this program live, Thursday, March 17th, or in rebroadcast on Saturday, March 19th, you're hearing the show that is going to be on tonight. I'm going to be tuning in. I can't wait. What do you think he's going to say?
Well, Professor Krauss is a very interesting guy. He's a physicist, as you mentioned. He's written a book called A Universe from Nothing, and he has a particular take on cosmology that suggests to him that the universe can be explained certainly without a creator, and could have arisen from literally nothing physical. So it's kind of a fascinating and provocative thesis, and I'm really looking forward to the conversation with him about it. In this particular debate or discussion, there'll be a third person as well, a theistic evolutionist who holds the view that I used to hold, Dennis Lamoureux, who is a biologist and a theologian. And so it should be an interesting three-way conversation, and I'm quite looking forward to it. So,
well, I got to say I am too. How exciting! Have you ever debated this guy before?
Professor Krauss and I have debated twice. Once in front of the Ohio State Board of Education, and once on National Public Radio, Science Friday. So we're old hands, and I've enjoyed the interactions with him. He's quite a bright fellow, and it should be pretty stimulating.
And now nobody has really voted the winner. We just get to watch and make our own conclusions.
I guess everyone draws their own conclusions and such things.
All right. Wow, I can't wait. I'm going to post information about that on my website as well in the archives at kmashow.com. So if you missed all that, don't panic. It's at evolutionnews.org from 7 to 9 p.m. on Saturday, March 19th. That's 2016. So I hope you, like me, will be tuning in and get a chance to see Stephen Meyer defending these views in person. Can't wait. Stephen, thank you so much. As a fellow Christian, want to thank you, and also as a fellow scientist as well. All right, God bless you. And thanks to the listeners as well. Bye-bye.